would be good to see you face to face, sir, but we really appreciate you getting up at 1 in the morning and presenting here. So do we not have Neil?
So Neil, your microphone has been enabled, which means you can connect it. And then if you're having any issues with connecting, we emailed you the call-in information a little bit ago.
Yeah, that's what it appears.
Okay, can you move the slides? No, sorry, go back to the front one, please. Okay, folks, I hope you can hear me. It's what, 7 a.m. in the morning, so I'm a little bit tired. I've had a few coffees, but we'll see how we go on. Just to the front slide, I tried to produce a virtual kangaroo, and that's the best I could do. So on to the next slide, please. Okay, so we've been fairly active in a number of areas. Yes, I think we are on a lag. So I'll talk to the slides. Just let me know if there are problems, but we are on a lag. I can certainly hear that. So we've been involved in a number of activities over the year. Technology to the target, repairs, and particularly in the area of coating. We've released a number of repairs. I won't go into details, but those items that I have in green are the items that I'm going to talk to. Next slide, please. Okay, so we've had some significant achievement in the coating area. What has happened in Australia, it's the first time in over 60 years we've actually built an aircraft. It's a very large drone. It's being produced by Boeing. The Australian government has ordered 3 of these in the initial order. And as you can see from the picture, it's supposed to operate with some of our aircraft, the AWACS and even the F-35. RUAG has a contract to build the undercarriages. And as part of that, we offered up SPD as an alternate to existing coatings and also in replacement for HVOF. So we'll be applying this to about 60 components across 3 prototype ship sets. The objective was to see if we could actually come up with a coating on stainless steels, and there's some aluminium alloy items as well. In lieu of existing coatings, that's both hard chrome and HVOF. So we've had to modify our system for the deposition. We've also modified powder types, so we've selected and generated a particular powder type, put it through all forms of testing, and we've had some success. Next slide, please. So as you can see, we've put it on a whole range of parts, about 11 parts in all. Some of them are quite large or long. We have deposited it down as a single coat. The challenge has not been the deposition. The challenge has been, in fact, the post-deposition machining or grinding. That's given our folks some challenges, but we've been able to successfully deliver that. So that is effectively an OEM approved deposition on a new aircraft type. So that's quite significant from where we see it. There's some other I've mentioned aluminium alloys, but some other alloy steels and some nickel alloys as well. So we've been able to achieve that deposition on all of those components. Those components have been tested. It's been gone through drop test and all of those sort of things. So it stood up very, very well. Next slide. The other area that we've been playing with is to basically see if we could develop repairs to some of the let's say, more exotic coatings, particularly electroless nickel. That's a particularly difficult one to repair. What we've been doing there is to look at opportunities to do localized repair. The current repair strategy is that you've got to strip the e-nickel off and replate, and that's a long process. It's quite a difficult process. So what we've done is that we've basically seen if we can actually deposit, blend out areas and actually deposit on the substrate, and more importantly to be able to get good bonding between our SPD deposition and electroless nickel deposition. We tried a number of nickel alloy based powders. We've come up with one which is performing quite well, and again, as we do always, we've put it through a number of significant tests and experimentation to make sure that it will meet the requirement. Next slide, please. So it's a nickel chrome carbide solution. It certainly meets the wear resistance requirement and the hardness requirements. It satisfies the corrosion resistance. We didn't see any issues with the similar metals. And if you look at the micro sections there, you can see basically how the deposition is adhering to the microstructure, or to the substrate and the chrome. We've effectively released that now as an approved repair, and that will certainly assist us in turning product back into service very quickly. The next slide, thanks. You've already heard some of this. We have been working very, very closely with VRC and the US Navy to develop the Brolga system, the portable system. It has an extended arm, so we can basically access things at height and things far away from the aeroplane. We've got very, very good feedback from those trials. We can actually tailor it, we can modify it so that we've got different power systems, and we can either cage it with nitrogen, cage it with helium, or adapt it to have external gas. What we have done now is, based on that success, we have set up a teaming agreement with VRC. It's a long-term agreement, and really what it is to exploit the concept of the portability, the extendability, the robotics and the handheld. So we expect that to see a lot more of those in the field. I think, as Rob Reevy mentioned, is that a possible solution, certainly solutions that we're looking at for our particular defence force, is to provide it as a service, not necessarily sell the equipment, but to deliver, as I say there, technology to the target. Next slide, please. We're just going to go through a couple of applications that we've been playing with. One of the requests was to look at whether we could post-heat treat SPD depositions, particularly aluminium alloy depositions, almost as an in situ process. Obviously, we're aware that the SPD deposition doesn't have the ductility of the substrate. So the concept there was to basically look at the post-heat treat. We have laser capability, so we looked at the potential of heat treating depositions with laser, and there are some pictures of what we were doing. And we were looking at a number of elements: microstructure, the effect on adhesion and hardness, and the mechanical property effect. Next slide, please. So what we've basically have done, these are the summary of the outcomes, is that the laser, the post-heat treatment, did not change or did not affect basically the microstructure. There was no improvements or reduction in porosity. It didn't affect the bond strength, so it added or didn't do anything there. We did see a slight reduction in the hardness of both the coating and the substrate. It was about 10%. That is a concern to us with this concept of in situ post-heat treating or localised in situ post-heat treating. Next slide, please. So what we basically saw is we really didn't see any difference in the tensile behaviour or the compression behaviour. We did see some elements of increase in some of the yield strength, but our concern was that our ability to control the tempering of the substrate. Very, very difficult with this this concept of localised post-heat treat. Hi, hello. Okay, I'm forgetting lag feedback. Okay, so next slide, please. Okay, so the outcomes are there is that for the aluminium depositions, the local or post-heat treat didn't yield any significant results. In fact, as I say, we are concerned with the potential to do damage to the substrate, so we've basically parked that as a concept for now. Next slide, please. So where do we go in the future? Where we're going in the future is that we're going to do some more structural integrity credits or further quantifiable. I presented last year where we'd seen some results of the SPD on a crutch structure. We're going to do continued fatigue evaluation under a full-scale fatigue test. Next slide. And also we work closely with Monash University, so we've done some work on crack growth behaviour and predictability, and we've done both the testing and the modelling, and we get very, very, very good correlation between the actual test results and the predictability. So that's where we're at. I'm not sure because if I can answer any questions, because obviously there's a volume issue here, but more importantly is there's a lot of feedback and a lot of lag coming in, so all I can do is deliver what I've done. I can ask for questions, but I've got no confidence that